Okay, so at this time we're going to put them all together and we're going to do a series parallel practice because you have the fundamentals for applying and solving for electrical parameters with series parallel. You're just going to apply the rules of series and the rules of parallel where they apply in the circuit. I would be remiss during this review to not give you a problem that involved doing a practice circuit redraw. So the first thing that we'll do is do a circuit redraw of this. Everyone get this example copy. So we'll start the redraw here. And we'll use the hangman method, beginning with the source on the positive terminal. We'll come up and around. Before I proceed with that basic starting point, I'm going to label my nodes. Question? Oh, 5K. If you didn't follow the pattern, my apologies. 5K. Okay, so I'll start up here. I'll call this node 1, node 2, node 3, and node 4. I think I've got all the nodes labeled. So I come out of the positive terminal of the source, I hit R1. Then I hit node 1. I'll start the hangman here with node 1. I make a right on node 1. I'm going to cross R2. I go down a little further out of the right side of R2, I hit the top of R4. I'm going to go back to node 1 and go straight down this time, or what I'm going to call left, and hit R3. From the bottom of R3, I hit node 2, which is also connected to node 3 at the bottom of R4. I'm going to combine those two nodes. I'll call it node 2/3. Out of the bottom of node 3, I hit the top of R7. Out of the left of node 2, I hit the top of R5. Out of the bottom of R7, I hit the right side of R6. Out of the left side of R6, I go up and around, and I hit node 4, which is also connected to the left side of R5. And that would be node 4 at that point. From node 4, I head back around to the negative terminal of the battery. And that covers the redraw for this circuit. Any questions on the redraw? Okay, now we'll go into two different methods for solving the electrical parameters here. Let's start with the equivalent circuit method. In doing the equivalent circuit method, I want to simplify the circuit to get it down to one resistive value, an equivalent resistant value, but what could also be perceived as the total resistance. In order to do so, I'm going to start combining the resistances. The first place I'll start will be in the bottom down here, and I see that I've got R7 and R6 in series. Those two in series, I can apply series resistance rules and get an equivalent resistance there, which would be what? Okay, so I'll get 13K right here. Call that RQ1, 13K, and then on the other side of it was R5 at 5K. All right, now I can consolidate here again with RQ1 and R5. There's two resistors in parallel. Let's use product over sum. So we would get 13K times 5K over 13K plus 5K. 13 times 5 is 65K squared, divided by 18K. What does that equal? 65 divided by 18? 3.61 ohms. Okay? We're going to backtrack back to this portion now, and I've got two series resistances here, which we would add together to give us 6K. So I'll place that on this portion right here. Call that RAQ2. And now for the resistance total here with these two parallel branches, again, I find I can use product over sum, taking 3K times 6K all over 3K plus 6K. 3 times 6 is 18K squared. 3K plus 6K is 9K, giving me 2K as my total. I'll write that in up here. That was RAQ3 down here. RAQ4 right there. And then up to R1, 1K. Any questions so far about making equivalent resistive values?